Hello everyone. On behalf of Transoft Solutions, I welcome you all to the fourth webinar in 2019 AutoTURN Tips webinar series. For those of you who don't already know me, I'm Charles Sebastian Chalucheri. I'm a civil technologist with Transoft Solutions, working in the product management team within the simulation business unit, which takes care of AutoTURN family of the products. Today, the presentation is all about evaluating the quality of swift path analysis. This presentation will be approximately 30 minutes long and followed by a short question and answer session. So if you're not able to address your questions during the Q&A session, we'll send you the answers by email. So feel free to enter the questions throughout the presentation. At the end, we will ask you to complete a 2-minute survey, as we really appreciate learning more about our customers and how you use the software. So with that, let's start. So here goes the agenda for today's webinar. I will start the presentation by explaining a bit about what swift path analysis is and the need for swift path analysis and also how it is done. After which, I'll briefly go over the major factors affecting swift path analysis and the advantages of using AutoTURN to create swift path of the vehicles. Then we shall see the points to keep in mind while creating a good simulation and the points to pay attention to while reviewing a simulation. After this, we'll jump onto our technical demo, and then also we'll talk about our project support services and move on to the question and answer session to conclude the presentation. So by the way, feel free to ask questions throughout the presentation. So what is swift path analysis? Swift path analysis is the tracking of a vehicle's simulated movements in relation to its geometry based upon its dimensions, chassis, and steering specifications. So this includes calculating the path inscribed by each wheel during the turn, and also analyzing the space required by the vehicle body to make the turn without interfering with any external obstacles. So the major vehicle parameters that involve in defining of the swept path width of the vehicle includes the length of the vehicle width, front overhang, wheelbase, rear overhang track width, steering lock angle, and number of vehicle parts. So one of the purposes of swept path analysis is to ensure that the physical area of the road has proper dimensions for the appropriate vehicles to pass through. Nowadays, the designs are being challenged more and more by the cities, who needs to be confident that the proposed layout is fit for its purpose, particularly for the sites where the space of the vehicle maneuver is limited. So planning for developmental projects sometimes needs to demonstrate that the plan layout can accommodate the movement of vehicles which is regularly expected on the site. So swept path analysis results can be a deciding factor for various design features. Like in the intersections, it can decide the radii of the curb, width of slip lane and receiving lanes, refuge islands, left turn geometry, median setbacks, etc. At roundabouts, the exit and entry curb radius, different various lane widths, truck apron widths, central and the bypass islands. It also helps in site development projects like checking the access and driveway layouts for the office and industrial complexes, car park design, truck docks and loading bay, gas stations, emergency and refuse vehicle analysis, construction vehicle access, and abnormal load route planning. It also helps in planning of transit terminals, constructing bus loop and turnaround areas, and also airport facilities. It also greatly helps to check the accessibility of vehicles and machineries on wheels in the inside of buildings, like in the warehouses. So the planners, architects, engineers, developers, and site owners are often required to perform swept path analysis for their sites or projects, as it helps them assess the space required for a wide variety of vehicle types without the need of physically driving the vehicles at any stage within the design process. This helps speed up the whole process and provides an easy and cost-efficient method for assessing different or alternative layouts or plans. So how is swept path analysis performed? In the past, turning templates were used to perform swept path analysis. These templates were printed physical sheets with a static or a fixed geometry and was in 2D. It also did not consider parameters like the vehicle speed, steering, and turning characteristics. Today, there are software solutions like AutoTURN to perform swept path analysis, which takes into account all these speed, steering, and the other turning characteristics of the vehicle. So, swept path analysis may include examining the following envelopes, which is the vehicle body envelope and the front and the rear tire envelope. So the vehicle body envelope is simply the space inscribed by the outer edges of the vehicle body. And the tire envelopes are the total space inscribed by the front and the rear tires to perform the maneuver. So the importance of deciding to which envelope to use is entirely based on the vehicle used and the project. So for example, if you're designing a rural intersection, while analyzing the swept path for a passenger car, it would be the best to check for the vehicle body envelope, as the passenger cars are not supposed to encroach over curbs or islands. Instead, for the same design, if we are to check for occasional buses or trucks, checking tire envelopes would be appropriate considering the space available and also that these larger vehicles possess a higher ground clearance that enable the front overhang of the vehicle body to pass over the curbs or the islands without causing a damage. So maximum swept path width. This is the section where the swept path of a vehicle is the widest for a particular maneuver. This factor helps dictate the minimum space required for a vehicle to perform the maneuver, like the minimum road width required to make a turn. Center line of the path. This is the path followed by the center of the front steering axle, and it has a direct effect on the swept path of the vehicle. AutoTURN calculates its swept path based on its center line. Clearance envelope. So the AutoTURN swept paths are non-conservative, or it does not include a safety factor. So if you want to provide an offset distance to the vehicle body, this extra clearance can be provided by using the clearance envelope wherever necessary. So even though the architects and engineers are often required to perform swept path analysis for their projects, they may only have received limited training on this topic. So improper usage of swept path analysis tools can adversely affect the design, causing operational inefficiencies, road safety hazards, increased construction cost, and may also cause damage to the vehicle and infrastructure. Hence, proper understanding of how to perform swept path analysis is necessary. What are the factors affecting swept path? So for all vehicles in general, the factors affecting swept path are the wheelbase, which is the distance between the center of the front and the rear axle group. So usually the longer the wheelbase, the wider will be the swept path. Next will be the steering lock angle. This is defined as the angle between the vehicle and the direction of the steered wheel. So the larger steering angle causes tighter turns and hence wider swept paths. So the center line radius of a turning vehicle is the lowest when the steering angle is at its maximum value. Next is vehicle position and orientation of the steering wheel at the starting point. So these wheels can be aligned parallel to the vehicle body or may be aligned at an angle, which has a direct influence on the swept path created. Next is the steering rate or the rate of change of steering. This factor accounts for the centripetal accelerations and affect the turning radius. The steering rate is also proportional to vehicle speed. So as the vehicle speed increases, the minimum turning radius also increases, which in turn reduces the swept path width. Lock-to-lock time. This is the time taken for an average driver to turn the wheels from the maximum possible steering angle on one side to the maximum angle on the other. So for a skilled driver, this value was found to be 4.8 seconds from our field tests. In order to cover a wider range of drivers from skilled to unskilled, we consider 6 seconds to be the default. Turn wheels from stop. This option is a direct override of the lock-to-lock time. It assumes that the wheels are already steered to a certain angle when the vehicle starts its movement, meaning that there is no transition portion for the path at all. For multi-part vehicle, such as articulated buses, semi-trailers, and other long combination vehicles, additional factors are included like the effective wheelbase, which is the distance between the connector to the center of the rear axle group, the linkage ratio between steering angle and articulating angle, and also the limits of the tractor trailer, which are the pitch, roll, and yaw angles. Now let's see what makes AutoTURN the industry standard in swept path analysis. So vehicles in AutoTURN are created to exact dimensions from reliable sources, which are design guidelines or the manufacturer technical specifications. So the software accurately calculates and displays a transition portion and a circular portion in the vehicle path, which is close to how the real-life vehicle behaves during the turn. The transition portion is the length required to change the steering from an initial angle to the steering angle to execute the turn, which is shown in the blue line as a blue line, and the circular portion is the portion of the path where the vehicle is turning at a steady state. So we have also collaborated and assisted with various design agencies and research boards such as AASHTO, CROW, TAC, IT, etc., as well as the various Department of Transportation in the development of design vehicles and turning templates. Like, for example, the 2011 AASHTO design vehicle and turning templates were actually created using AutoTURN. Also, over the 95% of US DOTs and over 400 cities and countries and over 80% of ENR top 100 transportation firms use AutoTURN as a reliable solution for swept path analysis. So all these factors collectively contribute in making AutoTURN the most reliable and accurate swept path solution in the industry. Our field test. So apart from the standard vehicle libraries, AutoTURN is also equipped with a manufacturer-based vehicle library, which consists of vehicles created from manufacturer specifications to exactly replicate the real-life vehicles. So when it comes to realistic vehicles, we have conducted numerous field tests on different vehicles, including passenger cars, rigid and articulated buses, semi-trailers, and even special transport vehicles, to verify the accuracy of the swept path created in AutoTURN. So from field tests, AutoTURN swept paths are measured to be accurate to about 3 to 4% of the maximum swept path width for the tested vehicle. Hence, it is not conservative or does not include a safety factor. So clearances, if needed, can be added at the designer's discretion or as required by the guideline. Our commitment to quality ensures that our vehicle libraries are relevant and up to date. We have constantly added new libraries to our database, and we ensure to include all the latest editions of design vehicles in our libraries. The software is currently equipped with more than 1,300 vehicles, including design vehicles from over 44 countries in the world, which makes AutoTURN the most comprehensive solution available in the market. As for innovation, we are constantly improving our tools to make the software more efficient, and more importantly, to provide an in-depth analysis to identify potential issues and prevent costly damages to vehicles and infrastructure. So our advanced simulation and analysis tools like the adaptive simulation and the smart path tools produces accurate results as well as provides greater flexibility in the usage. Standard design vehicle from the guidelines generally represent the worst case vehicle in its class. So therefore, a vehicle in real life may have a shorter dimension and can typically turn tighter. So if the designer would like to test a realistic vehicle, they can customize or create the vehicle in AutoTURN using vehicle creation tools, provided the dimensions and turning characteristics are handy. These values usually will be published by the manufacturers. Reporting tools. The software is also equipped with reporting tools like the turning report, which gives the change in steering angles, and the speed report tool, which provides a change in speed along a path. So all these sophisticated vehicle creation tools and simulation tools, together with all these reporting tools, makes AutoTURN the most advanced swift path analysis software in the industry. So as we have understood the importance of swift path analysis, how it is done, and major factors influencing swift path of a vehicle, now let's see how we can create a good simulation. The foremost important thing in creating a swift path is the vehicle selection. We should always select the right vehicle in order to be able to perform an accurate analysis, rather than assuming a larger vehicle will do the trick. The design vehicles from the guidelines can be found in the standard vehicle libraries, and also you can find the manufacturer-based vehicle libraries for vehicle created according to the specs from the manufacturers. Also, if you don't find the right vehicle in the libraries, you can create unique vehicles in the software if you have the specifications handy. Proper vehicle positioning and orientation. So the vehicle can be either aligned to an existing geometry in the drawing, or if we know the angle the vehicle needs to be aligned, we can enter it in the box to have the vehicle oriented. Using the right tools for analysis. There are different tools in AutoTURN which can be used to perform a swift path analysis, like the adaptive simulation and the dynamic smart path tools. So the adaptive simulation is a primitive tool to create swift path where the vehicle follows a predefined path, and it also does not take into concern the speed factor. Whereas smart path tools are dynamic tools to create a swift path which considers the speed of the vehicle and also considers super elevation and friction acting on the vehicle at higher speeds. Speed is another important factor which dictates the path followed by a vehicle. So the swept path of a vehicle narrows with the increase in the speed of the vehicle, and by slowing a vehicle down to an excessive low speed, a potentially challenging maneuver can be made easier. However, the vehicle speed contained within the simulation should always represent a speed at which the vehicle would perform such maneuvers in real life. A vehicle moving through a parking lot or a loading area will travel with less speed than they'll do on a highway or other roads. So it is important to keep check on the speed for accurate results. AutoTURN allows the flexibility to input different speeds for different sections within the created simulation, but the speed change will be instantaneous and no acceleration or deceleration is considered. It is always ideal to create a simulation with minimum number of sections or clicks in order to replicate the exact behavior of how the vehicle would be driven in real life, which may not be the case when the space of the vehicle, when the space available for the vehicle to turn is tight and the vehicle must do multiple forward and reverse maneuvers to reach its final position. Turn wheels from stop. This tool is to be only used when the vehicle is traveling at low speeds and when the vehicle would come to a complete stop in order to turn the tightest. So what the tool does is that it eliminates the transition portion, like we explained earlier, of the path, and can be easily explained as when the driver cranks the wheel to its full extent when the vehicle is still at a stop or static position. So a common maneuver for a fire truck or a garbage truck would be to perform a 3-point turn where the space is limited, and this movement can be replicated in AutoTURN making use of turn wheels from stop option. It is also not acceptable to utilize this option if the vehicle is traveling at a higher speed, like at the roundabouts or intersections. In order to properly analyze the swept path of a vehicle, the simulation created should be of suitable length so as to account for the vehicle, its parameters like length, width, and as well as its turning characteristics. The tightest maneuvers for a vehicle will often not be isolated individual terms. For example, if you have to analyze a horizontal curve along an alignment, ideally the simulation will also include extended lengths before and after the turn, rather than analyzing the curved portion alone. So this allows the space to illustrate the vehicle entering the curve in a stable position and also recovering to a steady position after the turn. So the appropriate length for a swept path simulation will depend upon the maneuver that is to be simulated. Apart from the factors mentioned previously, there are a few points to pay attention to while reviewing a simulation. So we should avoid designs where a vehicle utilizes unnecessary space. Occasional large vehicle maneuvers can be allowed to take up more space, like it's shown here, but high frequency cases such as buses on city roads should not pose a safety risk or intimidate the passengers or other pedestrians. And if a vehicle has to maneuver a tight turn, and if the vehicle body have to encroach upon an extra space, like the pedestrian footpath or any other islands or opposing traffic, we have to make sure that the tire envelopes are clearly displayed to illustrate that they do not cause any conflict. Displaying the path icons. So the path icons shows the direction of vehicle travel. Displaying or turning it on, like display or turn it on always, or for the simulations that include multiple forward or reverse maneuvers. So apart from the direction, path icons also represent the clicks within a simulation. And the distance between path icons are called sections of a swept path. And it's always ideal when the number of sections are minimum, unless it's really a tight space and the vehicle has to move back and forth. Conflict detection. So AutoTURN displays warning messages if it detects any conflict in the path of the vehicle. The geometry that has to be tested is to be added as an obstacle layer in order for the software to detect the conflict. In this case, the curb would be the obstacle, and if the vehicle encroaches onto the curb at any point, the software displays the warning message. AutoTURN swept path analysis is also capable of analyzing vertical clearance and the limits of tractor trailers, which are the pitch, roll, and yaw values. So if the vehicle encounters a steep grade change along its path with this advanced techniques, we can be well aware that none of the vehicle parameters are exceeded during the maneuver. If so, any of the parameters are exceeded, the simulation stops. Last is using the report tool. So if a vehicle maneuver through a roundabout or an intersection is analyzed, it will be the best to display a speed report for the path to make sure that the analysis is done with the right speed throughout. So with that, let's jump on to our technical demonstration to see and understand these mentioned points better. So today we shall be analyzing a commercial gas station site plan with an adjacent fast food restaurant drive-through and the vehicles accessing the sites. So the foremost point in any swept path analysis is selecting the right vehicle. So in this particular scenario, the vehicles entering the site will mainly access the gas station for filling the fuel, and the drive-through of the restaurant So majority of the vehicles that will be entering the drive-through will be passenger vehicles, and there may also be some single unit trucks or smaller trucks that will access the gas station for refueling, but not the drive-through because there is a height restriction of around 2 meters. There are also occasional garbage vehicle and delivery truck that has to access the loading bay at the back of the restaurant. And also, the site must be accessible by any emergency vehicles in case of emergencies. Our last month tip webinar was all about emergency vehicle access, So I won't be touching the topic in this demo, but feel free to visit our website, which is transoftsolutions.com webinars, to view the recorded session. So once again, coming back to the vehicle selection, to represent all the passenger cars that enter the drive-through, let's select a design vehicle, which is a worst case scenario for the vehicle. And as you know, all our vehicles and libraries are contained within the vehicle tools. Let's open the vehicle tool and let's select a passenger car from the latest AASHTO 2018 library. This vehicle will be the worst case representation of all the passenger vehicles that will enter the site. So click OK. Now that we have decided on the vehicle, let's select relevant tool to perform this analysis. So unlike the gas station, the drive-through access around the building is a predefined path. And it's a single path. So the vehicle enters from here, goes through the drive-through, and exits from here. And also the vehicle moves at very low speeds through the path. Hence, considering all these situations or scenarios, the most appropriate tool for this analysis would be the adaptive simulation tool. So here the vehicle is allowed to follow a predefined path, which can be a line or a polyline, and it does not consider the speed of the vehicle. So let's select adaptive simulation path, and let's click on the path of the vehicle, or the curb geometry in this case, which we want the vehicle to follow. So by default, you can see that the software creates a path centered on the path. But in this particular case, we would need the vehicle to follow the path offsetting right. So before that, let's see that this dialog says 31.6 degree max. So this says that the vehicle has attained its maximum steering angle possible, and in order to negotiate this turn, the steering angle has to be exceeded over the maximum possible value. So the software automatically detects when any of the vehicle parameters are exceeded and stops the simulation right away, and also displays a warning message. So as you know, the vehicle is intended to travel on the right side of the path. Let's offset it right. And now the offset distance is 5 foot from the curb, or our base geometry. Let's give an offset distance of 1.5 foot. And you can see the path automatically adjusts to the given offset. You can either give this offset as 0 or any other offset distance that you want to check the vehicle for. Now you can see that the vehicle passes through the drive-through without any conflicts. So if you have to check multiple vehicles, you can use adaptive simulation tool easily. And if the path is a single path, pre-drawn, predefined, then you can definitely use adaptive simulation for this purpose. So let's see. Let's try the same scenario with a larger vehicle like a delivery van. So just think about a UPS driver quickly trying to get his lunch burger through the drive-through or something like that. And what if we want to check what happens when a delivery vehicle, which is larger than the passenger car, enters to this drive-through? So we do have a delivery vehicle in our NACTO library. So let's navigate, select the delivery vehicle, click OK, and same procedure. Let's select the tool. And the advantage of adaptive simulation is that it remembers the last path which we used. So in order to do this analysis, just click use last path and it automatically creates a simulation. Once again, offsetting to the right automatically updates the offset which we used previously. And now we can see that there is a conflict that is detected by the vehicle. So you can clearly see that the vehicle body envelope is passing over the curb geometry. In order for AutoTURN to detect this outer curve geometry as a conflict, let's go to the properties, and to conflict analysis. So this curb geometry, the outer curb, has been added to the TS obstacle layer in AutoCAD, and that obstacle layer is selected as the obstacle layer in AutoTURN. So you can select any layers. Like if the curve geometry is in any of the other layers, you can select that layer as an obstacle. But in this case, I added this geometry to the TS obstacle layer in AutoCAD, which is the obstacle layer for AutoTURN to detect the conflicts. So now, in this case, if we, like we explained earlier, this is a delivery vehicle with higher ground clearance than the passenger car. So if we want to check the tire envelopes, if it can pass through, let's go to the properties back again, go to envelopes, and click the front and rear tires on, updated, and select the path which it has to be updated. So now the path is updated, and you can also clearly see that the tire envelopes is scrubbing on the curb. So clearly, this vehicle cannot pass through this particular drive-through with this like a 1.5 foot offset unless there's a design change made that the curb is widened, or like some other design changes made to accommodate this particular vehicle. So AutoTURN helps in analyzing the subpath, checking the obstacle conflicts against any geometries, and also helps in proposing design changes. Next, let's delete this for now. Now let's see the maneuver for a truck, like a delivery truck, which would occasionally access the loading dock or the loading area of the site. And let me select, let me go back to the ASHTO 2018 library, and let's select the SU40 commercial truck. So for this particular maneuver, it doesn't have a predefined path, and different drivers may use different paths to access this loading bay, because he has to come through one of the driveways, pull forward, and then pull the vehicle backwards, and so we're not sure about the path. Hence, in that case, we can use the Smart Path tools, which is the 2D arc path tool. So this is a dynamic tool and considers the speed of the vehicle. So selecting the tool, asks where to align the vehicle. So if we know the angle, we can enter it in the box. If not, we can have this pick geometry tool to pick this geometry of the road, and then we can align the vehicle wherever we want to. So the vehicle is aligned now, and then if we want to start from here, we can start. So now let's see the Smart Path tool window. So the turn wheels from stop option is turned on, which we do not need because we are traveling in an intersection, in an intersection roadway or a main roadway. And also the speed would be more than 3 kilometers for sure, like around 15 kilometers. And now let's drive, let's have this maneuver driven. 1 point, and the vehicle. So the vehicle makes a turn, goes forward, stops here, and now we have to reduce speed because it is a commercial complex and the vehicle travels in very low speed. And we can take the vehicle forward. Stop here. Now we can check the turn wheels from stop option because the vehicle stops and the driver looks around where to turn the vehicle to back up to the loading dock. You can see if you would take this maneuver and he backs up. So this would be how I would perform a maneuver, or some of the drivers would perform a maneuver, but it may be different for different drivers or like if different people are accessing the site. So how do we know that this simulation is the best, or this is a good simulation, how the driver would have performed it on road? So like we explained earlier, as important as selecting the vehicle and selecting the right tool, it's important to check the speed throughout the various sections of the simulation, which we already saw, and also check the number of sections. So the path icons shows the number of sections within the simulation. So in this simulation, there are 5 sections, which is ideal, which is okay, because the vehicle has to make a forward maneuver and a reverse maneuver back into the loading dock. It can also have more number of sections, which is entirely depending upon the user, but the minimum number of sections will be ideal. And then also we used the turn wheels from stop option to make the tightest turn once the vehicle comes to a complete stop near the loading way, like the driver would have done. So let's move the simulation for a second to here, and let's try on. So let's compare both of these simulations. The starting point and the ending point, or the final point of the vehicle, is the same, but you can see here that the vehicle makes, like, the number of sections are more, and the vehicle makes abrupt turns here that is, they might have used turn wheels from stop for creating the simulation, and there are the number of section is congested in here while reversing. So this maneuver, or this may not be possible in real life with a real vehicle. So considering all these factors, it's easier to identify how the simulation was created in the software, and it can be reviewed. Well, let's consider one more scenario for this to wind up today's demonstration. So you have been given this simulation, which is for a WB40 from AASHTO 2018 library. And how do you check if this simulation is good, or how do you review this simulation is perfect? So while seeing, it is clear that for smaller intersections, the larger trucks, they do take up 2 lane space, which is fine, and the vehicle has done the same, and the vehicle has come to stop at the stop sign, which is still fine, and the vehicle turns, but it encroaches upon to the other lane, which is desirable, or which can be permitted. So how do you check if the simulation is perfect? There comes our speed report. So there is a tool which says generate report, and we can generate. So when we select the simulation tool, we have to select the simulation. Then it asks us which speed report. My bad. So which report to create? So there is speed profile report and a turning report. So for this particular maneuver, let's create a speed profile report. This is the dialog box. We can change all the values and change the colors and everything which we want to. We can set the scale. There are other formatting options. Let's place this report and see what it says. Once I place this report, AutoTURN shows or displays the speed with which the vehicle travels along the path at different sections, or where the speed changes. So this is like 0 to 5 kilometers, and then this is gradual change. So AutoTURN displays the speed, and now you can see at regular intervals at the points where the click has happened, or the path icon shows up, the speed is 0 miles per hour, which is not desirable in case of intersection or roundabout or any other roadway. So if you can see here, this is 0 miles per hour speed, which is not ideal. So this simulation, it's clear that simulation has been created using turn wheels from stop, which shouldn't have been used. So you can also see the speed report, and you can see that the speed constantly touches the 0 point again and again, which which clarifies that the simulation is not ideal and you have to redo without using the turn wheels from stop and using the proper speed for the maneuver. So with that, let's jump back into our slides, and thank you so much for your patience. So the value of swept path analysis lies not in simply illustrating vehicle movements within a design, but rather to identify which vehicles can safely navigate the design, and if they cannot, provide validated insight into where the issues occur, and also to help identify and apply corrective or alternative measures. So as we already know, one of the most important factors in accurate swept path analysis is using the proper vehicle. So Transoft's Project Support Services team of engineers offers the custom vehicle creation service to help you model unique vehicles which are not currently available within the AutoTURN's vehicle libraries. For example, if you want to model a specific vehicle from a manufacturer or design guideline for your project, our service can create the vehicle for you for a small fee so that you can perform an accurate analysis. If you're interested in availing this service, simply contact our engineers at pss@transoftsolutions.com and provide them the required vehicle information like the vehicle dimensions, steering characteristics, profile drawings, etc. And based on the information, we can provide you a quote and an expected delivery time of the vehicle. We can also create special transport vehicles. So upcoming webinars, we do have a Guide Design Plus webinar on April 23rd, which is Simplify Payment Marketing Designs. And then, as you know, we are back with 80 Tips webinar every third Wednesday of each month. And next month, 80 Tips will be the basics of Smart Path tools. So please do come back and watch the webinar. And feel free to get in touch with us with any questions or clarifications you have to our support at Transoft Solutions Global Technical Support. And any questions regarding the sales, contact sales@transoftsolutions.com.